Okay, good morning. In this class, we discuss the acidic nature of nitroalkanes. That means nitroalkanes are weakly acidic in nature. What is the reason for this acidic nature of nitroalkanes? So, nitroalkane, again same example, CH3NO2. This is our nitroalkane. Look at here. What is the reason for this acidic nature of nitroalkane? What do you mean by acidic nature? That means nitroalkane can displace proton. It can produce H plus ions, or you can see that when nitroalkanes are reacting with a base, it can form salt and water. That means nitroalkane can generate H plus ions. Why or how the nitroalkane can produce H plus ions? What is the reason to produce H plus ion? Look at here. CH3 can be written as CHH. Okay, what is the actual structure of NO2? N double bond O, and here it is O. Okay, and we know that you might have studied this NO2 group is electron withdrawing group. NO2 group is electron withdrawing group. That means minus I effect. The electron withdrawing group, NO2 group is electron withdrawing group. It is withdrawing. It is pulling the electrons away from carbon. From there it is withdrawing the electron towards this direction. Therefore, what will happen? This HC bond here electron also move down. Here also it is moving from hydrogen to carbon. Here also it is moving from hydrogen to carbon. That means now if a base is coming OH minus, the base can immediately take this proton because of the electron withdrawing effect of NO2 group. NO2 group is pulling the electron away from carbon and towards NO2 group. That effect will be on these hydrogen atoms. That means what is that? Since the electrons are moving here, this electron will move down. Therefore, what will happen? The removal of H plus is easier. Okay, that is the first reason due to why it is acidic in nature. Acidic property of nitroalkanes. Nitroalkane. First reason. What is the first reason? Presence of electron withdrawing group. Electron withdrawing NO2 group, presence of electron withdrawing NO2 group. Okay, so will make the presence of electron withdrawing NO2 group will make the alpha hydrogen. This hydrogen is known as alpha hydrogen. Will make the alpha hydrogen more acidic. Will make the alpha hydrogen more acidic. That means NO2 group attached to carbon is alpha carbon. The hydrogen atoms present on the alpha carbon, they are known as alpha hydrogens. Due to the presence of NO2 group, this alpha hydrogen will become more acidic. That means will have more tendency to move as H plus ions due to the presence of NO2 group. That is the first reason. Presence of electron withdrawing group NO2 group will make the alpha hydrogens more acidic. That means if a base comes, what will happen? Immediately that hydrogen can be removed due to the presence of NO2 group. This is the first reason. Now second reason, look at here. So this is again, I am writing only one hydrogen, I am showing H, and here it is N double bond O, and here it is O. As I told you, OH base is coming. The base removes this proton. Okay, base removes this proton. Then what will happen? Earlier we have discussed this bond is shifting to here. Okay, that is there. But actually, what is the first step happening here? When the base removes this proton, initially what is happening? This bond, this pair of electron is first moving to carbon. Then what we get? When it is moving to carbon, we get a structure like this, CH2. Here it will become a pair of electron and a negative charge, and N double bond O, and here it is O. You are getting a negative charge on the carbon. That is what is known as a carbanion. You are getting a carbanion. Okay. Suppose if this negative charge is localized, is remaining on this carbon. Suppose if it is here only, it is not moving from this carbon, what will happen? This negative charge will attract back this removed proton. Then what is that? We cannot say there is a possibility of forming H plus ion, no possibility. Okay, so now, but here it is not like that. This negative charge is delocalized. That means this negative charge is shifting to here, correct? That time what will happen? One of the double bond is moving to this oxygen. You get a resonance structure like this. What is that? CH2 double bond N. Here it is O minus and here it is a coordinate bond. Okay, and in the next stage what will happen? Again, this will go back and what is happening? This is coming back to carbon. That means this carbon ion can be stabilized by resonance. Carbon ion can be stabilized by resonance. Therefore, the removal of H plus is not a very big thing. The removal of H plus is easier. Once again, I am repeating. Suppose this shifting is not there. Imagine like that. This negative charge is here only. Then what will happen? The removed H plus, this removed H plus will be attracted back because the negative charge is here only. So what will happen? The removal of H plus is not easier. That means it is not acidic. But it is not happening like that. Actually, what is after the removal of H plus, instead of concentrating the negative charge on this carbon, what will happen to this negative charge? This negative charge will undergo resonance, or the negative charge is undergoing delocalization. This negative charge is coming to here, this is going here, and this will repeat. That means after the removal of proton, the carbon ion can be stabilized by itself, so it will simply allow the H plus to go. These are the two reasons why nitroalkanes are acidic in nature. Clear? So, these are the beginning part of nitroalkanes. So, aliphatic nitro compounds are classified into two: nitroalkanes and alkyl nitrides. In nitroalkanes, alkyl group is directly attached to carbon, and in alkyl nitrides, alkyl group is attached to oxygen. Now we are studying nitroalkanes. Nitroalkanes can exist in two forms, which are the nitro form and acid form. In the equilibrium condition, we can see that the equilibrium have always a tendency to shift towards nitro form. Why? Because nitro form is more stable than acid form. The first reason is that nitro form can be stabilized by resonance. Second one, in order to form acid form, what is that? There must be an external base. Then followed by acidification only, it will change into acid form. And in this class, we have discussed why nitroalkanes are acidic in nature. We know that due to the presence of NO2 group is electron withdrawing group. The electron withdrawing group will make, what will happen? The alpha hydrogen atom more acidic. That means a base can easily remove the proton or from the alpha carbon, or it can remove alpha hydrogen. Second reason, after the removal of alpha hydrogen, the carbon ion can be stabilized itself by resonance. Okay, these are the reason why nitroalkanes are weakly acidic in nature, and we will continue in the next video. Thank you.